right, part C. So here's something interesting that's happening. We're seeing patterns in the powers of 2.
Yeah.
And we're also seeing some interesting evens and odds stuff. So what sort of things do you know about powers of 2? What are some other things that you know that involve powers of 2?
Well,
Even if they don't seem related, maybe they're going to come into play here.
Well, the powers of 2 get big fast.
That's true.
There obviously, no powers of 2 are primes except for 2.
Right, no powers of 2 are prime.
But what else do they appear in?
Anything that is there anything that you know that involves powers of 2?
What do we know about it? I'm not sure.
Well, let's brainstorm. Anything at all in math that you learned about that has powers of 2?
Well, we have done a couple projects with that.
Yeah, we sure have.
Though, I guess the areas wouldn't always have powers of 2 in them.
Yeah. But there are a couple special things that we've studied that relate to powers of 2.
I don't seem to remember any of them.
Okay, well, let me do what Dan Anderson did on his thing. To make the calculations easier, since the numbers are getting bigger, he just said, if it's odd, I'll write a 1, and if it's even, I'll write a 0. So he's going to do
in binary.
write it, not in binary, but in mod 2. Okay. But it's interesting that that made you think of binary, because why might binary be relevant?
It's base 2.
So now when you have a 1 and a 1, it adds to a 0. A 1 and a 0 adds to be 1. See, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0.
I see something.
Kind
I
of
see
looks-
Sierpinski's triangle in here.
Huh, looks like Sierpinski's triangle is showing up.
Interesting. Well, what would that mean?
Did you expect that?
No.
Didn't expect that. And you also mentioned binary.
Although,
How would binary come into play here?
well, maybe we could look at the numbers that were formed by them.
In binary, so this would be the number 1, 3, 5.
Then this one would be, maybe 8. And this is
Well, these numbers are getting big real fast. And our numbers here are not getting super big super
No.
fast. So maybe there's something else we could look at in binary.
well, maybe these numbers in binary.
Okay. How do you write 0 in binary?
Well,
0.
just 0.
Okay. How do you write 1 in binary?
1.
How do you write 2 in binary?
1, 0.
0.
And
3.
3 is
Was
1,
1,
1.
And then 1, 0, 0. 1, 0, 1. 1,
Wait, are we looking at these numbers?
We're looking at the row numbers
Okay.
in binary.
0.
1, 1, 0.
And
1, 1, 1.
Then 1, 1, 1. Like 1, 0,
1,
0,
0,
0, 0.
Okay. Do you see any connection between these numbers? And then the numbers over here. The 1, 2, 2, 4, 2, 4, 4, 8, 2.
well, the 2 twos have a 1 and then the rest of the digits are zeros.
Okay. What do the 4s have?
They have.
Looks like they have 2 1s.
Okay. So the 2s have 1 1. The 4s have 2 1s. How about the 8?
The 8 has 3 1s. So 16 should have 4 1s.
Okay. So what's the connection? How do I go from this number in binary to this number here?
Well, for the powers of 2, if it's like 2 cubed, there would be 3 1s.
Right.
Or
So
3
2
zeros.
two-
Oh yeah. Okay.
2 to the n would be.
There would be n 1s.
2 to the n, where you have n 1s in binary. That's interesting. That seems to be a pattern.
Let's see. Well,
Should we go try to look and see what 2015 is in binary?
Alright.
Okay.
On Wolfram Alpha maybe?
Yeah, just because you guys have to run. So let's go to Wolfram Alpha and do that real quick.